Good evening to all. Last class we have seen problem 1, subdivision 2 and 3. This class we will see subdivision 3 from subdivision 3. So what is the set given for this question? 1, 2, 3, 4, 5 and 6. So relation R is given that set of all ordered pair x comma y, that is y is divisible by x, the ordered pair. We have to take x comma y. Here the relation between x and y, what does that means? Y is divisible by x. So we will check first reflexivity. So when it is reflexive, what is the definition of reflexive? We have to show that x comma x belongs to R, or a comma a belongs to R for all x belongs to R. So this question we can prove by two methods. First one, we are taking the elements, what are the elements will satisfy, what are the values of x and y satisfy all the ordered pairs we are writing, and we will check that. Another method is we will prove analytically. So how to prove? That is the second method is easiest method to prove this. Okay, so first we will take it as relation R x comma y such that y is divisible by x. So what is first property? Reflexivity. What is the first relation? Reflexivity relation we are going to check. So reflexivity means we know that x comma x belongs to relation because x is divisible by x. Every number is divisible by itself. So clearly we can say that x is divisible by x. So x comma x belongs to R. So we can decide R is reflexive. We can say that R is reflexive. Okay, what about symmetric? Symmetric means what? X comma y. If x comma y belongs to R, then y comma x also belongs to R. If x comma y belongs to R, implies y comma x belongs to R. We have to prove. Clear? So clearly we can give an example. A number is divisible by another number means the second number may not be divisible by first number. For example, I am taking 2 comma 6. Here 2 comma 6. Here 2 comma 6 belongs to R because what is the reason? Because second number is divisible by first number, that is because 6 is divisible by 2, but 2 is not divisible by 6. Only one example is enough to prove that it is not true. So I can say that 6 comma 2 does not belongs to R. See that 2 comma 6 belongs to R, but 6 comma 2 does not belongs to R, but 6 comma 2 does not belongs to R. So what I can decide? R is not symmetric. R is not symmetric. So reflexivity over, symmetric over. Next we will check the transitivity. We will check the transitivity. So how to check transitivity? Transitivity definition is what? X comma y belongs to R, y comma z belongs to R, then x comma z also belongs to R. X comma y should be in the relation, y comma z should belongs to R. Next x comma z also should belongs to R. Or we can take it as ABC also. Whatever it is, both are equal. In terms of ABC also we can say, or in terms of XYZ also we can say. No problem. Our problem regarding XY, so I am telling in terms of XY. Clear? So check that transitivity. If x comma y belongs to relation and y comma z also belongs to relation. So why I'm going to prove? I'm not going to prove by giving examples. I'm going to prove generally. So x comma y belongs to R, y comma z belongs to R means what is the relation between x and y and z? Here then y is divisible by x. Y is divisible by x. So y is divisible by x means x must be a factor of y. X is a factor of y. So I can write that y equal to some constant, that is k1 into x. Similarly, z is divisible. Z is divisible by y, because y comma z belongs to r, so z is divisible by y. So z is divisible by y means y is a factor of z. So how we can write z equal to some constant k2 into y. So already we have find the value of y here, y equal to k1 into x. So substitute now, y equal to k1 into x, substitute here. So z equal to k2 into k1 into x. So this is equal to what? Z equal to some constant, because k1 is a constant, k2 is a constant. Multiplication of two constant is also a constant. So k3 into x. So I got z equal to k3 into x means x is a factor of z. So z is divisible by x. Z is divisible by x means what we can say? X comma z belongs to r. So I have taken x comma y belongs to r, y comma z belongs to r. I proved that x comma z belongs to r. So I can say that r is what? Transitive. R is transitive. So this problem, r is reflexive but not symmetric and transitive. So r is not symmetric but reflexive and transitive. Clear? Next question number 4. So here what is given? The set A equal to set of all integers, and the relation given here, relation set of all ordered pairs x comma y. X minus y is an integer. X minus y is an integer. So first we will prove reflexivity. So what is reflexivity? We know that 0 is an integer. Clear? 0 is an integer. This 0 can be written as x minus x. So 0 is an integer means x minus 6 also an integer. So x minus x is an integer. X minus x an integer means what? How we can write? X comma x belongs to r. Therefore r is reflexive. Next, symmetry. So what is symmetry? If x comma y belongs to r, then y comma x also belongs to r. This is a symmetric property. Okay, so check now. If x comma y belongs to the relation, that is, what is the relation between x and y? X minus y is an integer. X minus y is an integer. If x minus y is an positive integer means y minus x is also an integer. What type of integer? If x minus y is positive integer means y minus is a negative integer. If y minus x is a if x minus y is a negative integer means y minus x will be a positive integer. Anyhow, x minus y is an integer means at all the cases y minus is x also an integer. So we can write y comma x belongs to r. So I can say that r is symmetric. Okay, reflexivity over, symmetry over. Next I need to prove the transitivity. Okay, transitivity. So what is transitivity? A comma b or x comma y we have taken here. So x comma y belongs to r and y comma z belongs to r. Then we have to prove x comma z belongs to r. This is the transitive property. Clear? So what we have to take? If x comma y belongs to R and y comma z belongs to R. So what is the meaning of x comma y belongs to R? That is x minus y and y minus z are integers. We know that sum of two integers is also an integer. Sum of two integers is also an integer. So what we can write? Sum of two integers is also an integer means we can write this sum. So x minus y plus y minus z. X minus y plus y minus z can be written as, these two will get cancelled, we will get it at x minus z. If these two are integer means x minus z clearly an integer. So I can say that x minus z belongs to R. So R is transitive. So already we proved R is an reflexive, R is symmetric and R is transitive. So the given relation is reflexive, symmetric and transitive. Clear? Okay. Next class we will see the remaining problems. Thank you.